From the same page 526 in the technical drawing, I've kind of stared at this one, and the little bit of fingernail down here kept throwing me, but really it's the projection of this line, and you can kind of see the partial arc. So one of the questions that is recurring, or that I'm being a little more focused on at these little more complex models, is making sure that I have at least a decent picture of what I'm starting in on. All right, so as it relates to the CSWA, things that you won't be doing, you should not be seeing bilateral dimensions or limit dimensions. All right, tolerances are goes from let's just say 176. My natural tendency is to go to the 1.758. All right, which is the maximum material condition. So a number is going to fit in there. So rounding it off or something that's more nominal would probably be where we end up. So looking at this cutaway, this back wall transitions and becomes this back wall. And a couple of the topics that are still introducing is, do we need this as an assembly? Do I need it as just a part number? And what is the function? We're given a fairly tight tolerance. We'll go to the nominal dimension, 2.750 on the bore. But usually a clamping surface like that is going to have some type of gap. This is showing that it is full contact. So if it is, they're calling it a rack slide. So if there's a piece of pipe that goes in there, or a piece of tubing that goes in there, and it clamps, depending on the tolerance of the tube, we could have everything from a crush fit to a slip. All right, so we'd have to look at what we want for that geometry. So I'm going to stay with the contours and regions on this. I like the ability to sketch all this geometry out, and then pick if I'm going to use shared sketch or if I'm going to treat it as a layout sketch. Right, so let's fly this out of the way. Oh, where did my SOLIDWORKS go? All right, so inch, pounds, and seconds. Again, metric. So this would also be an interesting one, since most of these say redesign to metric. And we haven't really done that, but recognizing a lot of these numbers are within probably 5, 10,000, somewhere pretty close to our nominal inch numbers. It shouldn't be that difficult to change this over to metric. So maybe we'll start on that and see how far we get. All right, so front plane. Question is bottom middle, bottom back. Kind of looking at this. I'm thinking that, at least from the sketch, I'm going to put the origin at the bottom, kind of halfway at the middle of the rib. Mainly, that's going to assist my my sketch, and then we'll move the coordinate system around again, just to revisit those. All right, so I'm in the front plane. Make sure I pick up my my midpoint. We have an overall of 12 inches, so a fairly good sized part. And the height, 2.5. And then if I may not need it, but I'll go ahead and put in the step just so that I can. It'll help me visualize. So 1.75. All right, and for depths, and then the circles. A couple of concentric circles, and from the base, and another one of those. Well, we have limit dimensions, so let's see which one we want to use. So 4833, 4832. That's pretty close at 1,000. So yeah, I would really pick one. I don't think it's going to matter much on the center of mass without one way or the other. So let's go with the even number, 4.832. All right, and then our diameters. Outside diameter, radius of 3.38, so times 2. And then I can kind of see where that overlap, that intersection is back to the through the undercut. The through bore, so we're going to go with the nominal 2.75. And then position, I'm still in blue, so clicking that center point and dragging it, that shows me that I'm not able to move up and down, but I am able to move left to right. So since I'm on that, going to be at the center of the part, I'm just going to make that go back vertical. All right. Let's check out the ribs here real quick. So we really don't have a distance. We have the 45. If that's coming off off center, right, where the split is, and then comes down 45, we're just looking for that intersection. So find the quadrant. And that certainly doesn't look as, or that looks a lot closer than the 1. Oh, that would be because I need another circle in there. So where is that that dimension at? Because the 3.38 was to the outside, the 4-inch goes to center, the outside of the cap. Let's see. 4.5. There we go. It's hidden in there somewhere, so that should help a little bit. All right, so if I take that coincidence off, just let me drag, and then I can go coincident to the inner circle. That looks a little bit better. So since this one might get confusing, or probably will get confusing for just the cut, this would be a good one just to make for construction. Well, same here, is just making those for construction. It'll shift the focus. All right, and then for that that rib, I'll just go ahead and mirror it. That way it shows up on both sides. All right, so except for the caps, I know that I'm going to need some geometry. Well, did not really intend to make a plane there, but since I have it, now that would shift the origin. Like I say, we could move the origin to the center of the piece, and that would make my sketching easier. But now I'm moving away from what I decided or what was given to me as the origin. So even though my natural tendency is to, let's make this easier, I'd rather just go ahead and create the plane. All right, so again, I don't expect to see planes. I don't expect to see some of this geometry, but these are still things that you want to be prepared for and know when to use them, how to use them. All right, so let's go with the shared sketch. I'm going to extrude out, and I'm just going to pick the contour. It's going to come out some distance. All right, so that was 3.375. Gives me the first. Go back into the sketch. All right. Oh, well, I guess I didn't really need to get back into the sketch. I need to highlight the sketch and then extrude. All right, and then the ribs are going to come out to that face, and those were 0.938, so 15/16. And then the question is, if I include this geometry up to that face, then I still have to move it back. So I'm going to go ahead and make that one separate, because I should be able to now pick the region, and the from goes to surface and face, so or vertex. When I reverse the direction, we have an overall of 3.25. So the from shifts to what I just created, and then my direction goes back. Otherwise, I would be direction 1, 0.938, direction 2, 3.25 minus 0.938. Yeah, I'll never do that math in my head. Okay, close to doing that math in my head. All right, so that gives me the desired geometry. All right, so let's go ahead with the end, and that could be in the middle. Don't know that it much matters. I'm going to right click and select the midpoint, control select, pick up my next midpoint, my dimensions. The 1.76, and then I made that sketch, or made that part of the sketch. So if I want to use that construction line, that construction geometry, then I have to come up with a way to make it coincident. So the endpoint is going to be preferable to the line, to go with the line. If I tried the endpoint and endpoint, I might get those horizontal. All right, so horizontal would probably work. We're going to extrude cut and then go through all. All right. So, said that this face and this face were going to end up being the cutting nominal distance or normal distance 0.131. So that means that this cut is going to start a little bit backwards of that face. All right, so that a little bit of relief. All right, so that little bit of relief and the setback, that's going to come from that face being coplanar all the way through. All right, so I can just start the sketch on that face, and this time I will convert the entities. Features, extrude cut, reverse the direction, let it go through all, and we have just that little bit of end relief.
All right, so that's for the sleeve of the pipe or something.
Yeah, I got a flange or connector going there. Yeah. So, as far as the next bit of geometry, my concern is all of these radiuses coming together. We may eliminate the radiuses again and just leave sharps. In fact, I'm inclined to leave the sharps at this point. So, all right. So, getting the little ears, we're going to go with a plane. So the center point and the top plane, if I pre-select, I'm going to be able to create a parallel plane through that point. And then when I open the sketch on that plane, my intersecting geometry, and the question would be, let's go, we'll get a center line. I think that's relatively safe. Go ahead and make the mirror. So we can get the dimensions going. Radius of 0.875. And dimension between at 4 inch. And I'm making the assumption that I'm not going to break through into the through board. Right, so as soon as I break through the end of the through bore, that kind of changes my strategy. Right, so this this hole location was generated in the boss. Right, so if I go back and edit that feature, where I pick the region, I'm just going to, let's see, deselect and make it solid by going from region to contour. And then up to surface, oh, that changed from face. That was still blind, 3.25. Go ahead and accept. Well, not surprisingly, the sketch picked up because that in geometry changed a little bit. I'm going to end up with one dot in amber because that midpoint now is not able to calculate. So we'll just delete it. It can go back to being coincident. Don't really care where it comes back to. So we left off with 4 inches, and then we're pretty much centered. So the 1.63. Yeah, the tough decision is, am I going to be able to pick up a midpoint? Well, it kind of blends, and that midpoint is not a good choice, right? Because we eliminated the bore, and I don't want to build that out. So the choice would have been to trim this off, or at least make it connect. But I also know that this is going to come up, and it's almost going to be full circle by the time we make that split. So that being the case, let's go ahead with the 1.63, and I'll stay with the 2 decimals. Well, that shifts from the front to the back. I really want to make it 1.625, my OCD kicking in. And actually, if it's going to be an issue, I'm going to bring it from the front. All right, again, I can pick that arc because, let's see, does that math work out? 3.25. Okay, I do want to make sure it's centered then. I can pick that arc because the line projected, or the arc projected in. I'm getting 1490. So need to double check that I actually achieved 3.25. 3.12. We trimmed it back. So that 1/8 of an inch or so, that messed me up. Right, because I didn't have that geometry in to start with. So those are the kind of catches I'm looking for. Is as you go through the iterations, as it evolves, you're trying to pick up those items. All right, so that one was okay. That one's my problem, and I can't really. Let's see. Let's go back and. Oh, I'm in that sketch, so it won't let me do anything until I get out of that sketch. And my from face, I just naturally picked, and since I don't have the other faces there to work with, okay, so based on the ordering, let's see on the off chance, where did that one end up? Let's see, that was the very first piece, so I can reorder. All right, but you do want to be careful with the reordering. Are we changing anything fundamentally? And when I go back to pick up the face, now that the geometry is there, it exists. 3.25. All right, so that makes my correction, and it's a fairly easy fix. I can't count on that, though. Depending on the sequence and the order, I got a 50-50 shot. It's either going to work or I'm going to be trying something else. All right, so I do want to hide that real quick. I'll go back in. 1.63, 1.62. Those are the numbers I'm expecting to see. All right, if I had rounded that or hadn't rounded it and went to the 3 decimals, 1.625, that would be exactly mid. All right, and then the height that we're given, 1.375 and 1.375, so that would be 2.75. Go into the features, and then we're going to extrude. Let's see, if we do a mid-plane, then I can do the 2.75. Because those are dimensions separate, I may be safer telling it direction 1, 1.375, and then activating direction 2, and also going 1.375. All right, so if one of those was to change, grow or shrink or do whatever, I have at least that ability to update those geometries. All right, so we'll fly this in one more time. All right, so I'm kind of concentrating in and around the spot face, and so we have a radius 0.875, but then 906 through with a 1.5, and so the 0.875. Well, let's go ahead and pick that one up. I'm going to end up doing too much math in my head, and I'll have it all messed up. Alright, so that was the outside. Okay, yeah, that makes sense. So since I drew that, well, if I go to convert, I think I'm a little safer just drawing the circle and double checking the dimension. If I convert, then keep in mind that those endpoints, I can drag those back around and it will become a circle, even though I'm converting an arc. What I'm after is to cut extrude and finish the relief going into that corner. Alright, so see that there's going to be some blends, some other things going on. And then where this gets a little more interesting, we're probably at that stage where I could go ahead and put the hole through. So sketch 1, extrude cut, pick the region, the contour, and we'll go through both. And that's looking pretty good. Alright, so the question is, I know that I'm going to end up splitting this, or having to do something with the cap and the base. So let's save that for the last. I think I've taken that as far as I can. Pick up that geometry. We have the rib geometry, so let's try it with the rib again. And I'm kind of expecting that same type of issue. When you look at the blend, because this is pretty much hand drawn, you get that nice transition. Well, you know, even in the casting, even in the pattern that's the casting is going to be made from, that's going to be an interesting blend. So on the right plane, we'll open up the sketch, and we know that that's going from point to point. So really, I just want to make you aware of the limitations of the rib. And we'll see if that one, okay, so those pick up. All right, so I'm not concerned down here. I fully believe that that will not be an issue. As the curvature, as the cylinder falls away and has that, now it's trying to calculate that geometry. Oop, I guess we'll go back to where it was. I'm either going to have to extend out, or I'm going to have to pull this back so that it can match. Well, let's go ahead and try it. So let's see. We're under the features. We're in the rib. The direction. All right, so that splits it that way. So the first one was okay. We're going to flip the material side. Thickness is 0.75. And it is on the mid plane. All right, so both sides. And when I go to accept it, you can kind of see that those points aren't lining up with the cylinder. So that's pretty much where the issue lies. Alright, so we'll go back to side view. And I got one of the coincidences, not exactly the coincident that I wanted, so we'll see if we can pick that back up. And last time we had to space it down kind of far, so let's go with a 0.75 on that. Let's stay with the 1/8 inch and see if that can complete. Alright, so flip the material side, 0.75. We'll see if it can match the curvature. Alright, and so, let's see, can I get a measurement, evaluate? That's saying 0.097. Huh, I would have thought that would have ended up deeper. Either that or I need that point, so. I hate when that happens. Make sure I'm... Alright, so we'll see if it can rebuild at a millimeter. Alright, so I got a decent blend. I'm really close. I'm going to keep chasing it one more time. I'm basically looking for where it's going to feel. So at that point, I'm at where the points in the curvature kind of meet. Probably not more than 5 or 10 thousandths there, so I think we'll call that one good and leave it. Alright, get back to my geometry. Alright, so let's go ahead and suppress that one out, and in contrast, if we want to try and build that geometry, the CSWA3 example had that blend where I could go right to that corner. And then as long as I intersect in far enough and tie those back together,
that's what I ended up doing.
and then we extrude to 0.75, and that'll be a midplane. And so the difference is I have this kind of square step. And if we put a generous radius in there, because we're probably not going to, we're not going to machine to a square, and it's certainly not going to be cast to kind of that hard edge. So, either one, we could make a configuration and see what the difference in mass of having a little fingernail versus adding in that, a couple of cubic millimeters of material. All right, so a couple of choices, but you have to be aware of the geometry. All right, so we have the 3/8/16 on the bottom. So S key, I like to remind me to go into the whole wizard, and Control 6 will take it to the bottom. Let's stay with the tapped hole, bottom tapped hole, and we're going to go to the 3/8/16. Double checking my number there. And then blind in condition. With thread callout, watch out for the near side countersink if it calls out a countersink, but for the most part, usually we'll leave those turned off. We're not given the hole depth. All right, so the tapped hole. So we'll go with the thread depth and see if it updates. Blind hole depth, let's go 1.25. All right, get those to update. There we go. 1.437, and we're at 2.5, so that seems reasonable. So that would be an issue with our mass, is we're going with the calculated value. Since that hole depth is not specifically called out, I'm going to stay with the 1 7/16. We have four holes in the pattern. So that means that we can go midpoint and midpoint, and I'm trusting that I'm staying on center. So we'll get the first two in position, Control Select, make them horizontal. Between the two is going to be 3.25. All right, and that gives me enough to start my mirror. All right, so select, Control Select, the 2 points and the center line. I got into lasso, selection tools, box selection. I really want to go left to right so that I don't include the center line. I'm going to pick the opposite center line, mirror those entities. Now I can go in between, which was the 2 and 9/16, 2.563. And then between on the center was 3.5. All right, so because the original quadrant, over here, has the geometry, I can determine where the rest of the pattern is with the mirrors and the minimal amount of dimensions. If we wanted to check, wrong one. Let's go with the dimension. And anytime I just want a reference dimension, I can place it, make this dimension driven, and it will show up in the gray extension lines and not participate in the geometry. All right, so those look pretty good. Have that. All right, so we're going to see what we can do. And I'm going to try to put the spot face in first. And actually what we might do, this would be easier just to generate the 2 cut extrudes rather than trying to force it in with the hole wizard. But get into that mindset of making the hole wizard work. Problem is going to be that since this is not through that we're terminating at the plane, it's going to try to keep that drill point. So one of the things we could do is legacy, and on the legacy pick up the let's go with the counter board. And we have a blind in condition, so the through diameter is the 906. Maybe not. Counterbore diameter, counterbore depth. All right, so diameter, and then 1.375. We're going to see what this looks like anyway. And then 1.5. And a depth of, I know I saw it there, 0.062. So pretty much just making a spot face. And one time I thought they had something called a spot face, but we'll place it and we'll place it. Alright, so the issue becomes, let's go back over to that hidden lines. That one did come down to, and is showing a flat bottom. Alright, if I'd use the counter bore, I'm gonna have to deal with that drill point still. All right, so the legacy tool does have that basic advantage. All right, so the S key again. We're going to go back to the tapped hole. I did not check to see if we have a 7/8 9. Hey, how about that? We have a 7/8 9. It is up to next, which is one of the reasons why I picked the internal. Just depending on where this ends up on the intersection. Oh, they also put those reliefs on the backside. So something else you get to go back and check for. All right, so finding our centers. And since that breaks through and doesn't quite come to a cylinder, we'll need to roll back and pick up that geometry. All right, so this was about there. So grabbing the rollback, since I already have that geometry in place, we'll open up the sketch. The converting was okay. I think I like just having the circle, and we'll make those co-radial. Co-radial. Alright, so a couple different ways to approach the arcs and get that geometry in place. Features, extrude cut. We're going to reverse the direction. And just through all is fine. Shouldn't be intersecting. Ah, it did. So that would be something we would need to know. It is either the 1.625. Well, and up to next is going to find that. And manufacturing-wise, I'm not going to be able to, I'm going to have to machine that. It's going to touch that wall. So the 1.62 is already on the back side, so that would be something to go back and analyze. With that dimension, 3.375 being kind of open. All right, so I think I'm going to leave that one. Basically because I trust it that that's going to be my manufacturing process. I'm going to have to take a long end mill and open that up. Alright, so that gives me the geometry, but it does not give me the two pieces. So at some point I need to save this, and this is 13-19. Alright, so I think I have all of the geometry except the fillets. Oh, nope. We have an 1/8 inch chamfer that I do want to include. Alright, so at this point, if this is all I need for the part, minus the hex heads, I can call this a done part. I don't really have to take it any further. I can use this in the assembly, and it's representative, has the tolerances, has all of my base geometry, and probably most of the clearances. If we need this to go out to, well, let's do it on that plane. If we need this to be able to go out to our other geometry, no, I don't really want to be midpoint. So I want to watch that picking the midpoint thing. I just hid that so that I could come back and show it again. And pick that up as coincident. And what I'm creating is a tool that is going to split this part into two pieces. Alright, so this is pretty much, let's go ahead and hide that back so you can see the geometry. This is pretty much going to make two pieces, and if we tell it to the assembly. So under our, I'll make sure that one's selected. Insert a feature, and under features it's in split. Under molds it's also called split. Let's make sure that's the same thing I'm telling you, right? Yeah, pretty much the same icon. So split is going to ask for the parts. We're in our part inch, and do not have an assemblies on that group. So I'll go ahead and set up the assembly. And I did not have not named these. Alright, so let's see, if we go ahead and tell it to cut the part, then these are the two bodies that it's going to produce. And so if we name one the base, and one is the cap, alright, this is going to create that external reference, and let's see, override template. So unlike my other strategy, I'm not going to get the assembly out of split. I'm going to get the two parts, and then I would have to create the assembly. All right, and that's fine. If I don't need an assembly, I just need to manufacture the two parts or make it a solid body, then we can go ahead and do that. Alright, so there went the cap, and now I have two solid bodies, split 1, split 2. Going back into my part, then I should see there's the base without the cap, and there's the cap without the base. Okay, so I can work through it that way. Let's try it, because there are some rules to the multi-body part, the master model. One of them is that we don't really suppress. So let's stay with that one. And that did allow for the split. No, maybe not. Because that pulled the geometry out. Well, let's try it. Alright, so that's interesting. So strategy B then is to go up to the solid bodies. If I had named these something else, but I really want to see these, kind of retain the split. If I go into save bodies, if I insert into a new part, it's going to kind of do the same thing. Whichever one is selected just goes out to the part. If I save the bodies, part inch, go back and grab the assembly, and then auto-assign the names, it's going to pick up those solid body names, split 1 and split 2. Right, feature and then the items. Origin location is fine. Browse to create the assembly. Well, let's keep it with the split 1. And these are creating external references to where I'm ending up with a lot more files than what I normally would intend to. And this may be even something that I would go back and perform, put a line in that original sketch and make these separate bodies. I would have to decide on that strategy early on, right? Because now I have a couple of extra files. So the save bodies is holding on to that information, and there is the assembly. Right, so the assembly goes in, the two parts are fixed. That gives me the geometry, but then just like the split tool originally did, I end up with two files. So I think I'm confusing myself, so hopefully this isn't getting too carried away. Alright, so split 1 and split 2 were a product of the saved bodies, whereas the base and the cap were the product of the split. Alright, so whichever tool you use, I would probably not mix these. I'd pick a strategy and mix these. Just had, kind of convenient to illustrate the difference between the two functions. Alright, we get to this stage, then I can bring in the hex head screw from the toolbox. And since the toolbox is not loaded, we'll add in now. And ANSI inch. Bolts and screws. Let's go with the hex head. Let's see which one that picks up. And there we go. Drag and drop. You can do it. I know you can. 7/8 14. There's my 7/8 9. And lengthwise, we're probably 2 3/4. So there is a 2 3/4. Thread length of 2 inch, that should do it. All right, so we have the shoulder. Doesn't necessarily need to be threaded all the way. Go ahead and hit OK. That should take me into the next one. And we go ahead and accept. All right, and then the kind of the main difference here is these are free to rotate. All right, so we save all those back. So I'm trying to think what's different is the strategy would have been more along the lines of generating the cap and the body separate, or the base separate. So if I just had the two bodies, then that would be the save bodies from that top level. All right, so the split. Notice that it shows the stock. it refers back to geometry and the whole wizard cosmetic threads. But basically, that dash greater than symbol tells me that there's an external reference. All right, and that external reference, if the original, all right, my base piece that has all this geometry that's driving all of that geometry is not open, I'm going to see question marks. All right, so this opens with the assembly. This opens with those parts, so that it can make that direct connection back to the part. Pretty much same thing that we're going to see with the base and the cap is a dash greater than symbol. All right, so I have 2 or 3 methods that I can get that external reference. And when you see those external references, you want to be a little more careful. You want to be cautious because we've set up a spider's web. And when I start pulling on strings in the spider's web, I don't know what's going to come unravel. All right, so I have good functionality here. I can check for my geometry, and that looks like it may have gone a little deep. Oh, well, it wouldn't have been exactly 1.375 because it was on the cutback. I don't know. Pretty close. Might have to do a little adjustment on that one. So that one would have worked better as the cap.
And then to make a change to, say, the base or the cap, you want to go back to the master model here.
Right.
Do your change in it.
Yeah, the master model is driving all of that data downstream. So since the other parts don't have any geometry of its own, and then you also need to decide, am I going to put the oil hole at this level or that level? You know, it's kind of one of those, which one makes more sense if I'm driving this geometry? And, you know, I kind of developed that strategy, and all of a sudden I varied. You know, I want to make sure that I'm staying consistent with those choices. All right, so I put this in. It's going to allow me to take from that level forward and make changes, make adjustments. But this is not going to migrate back then. Now we go back to that original. There's no oil hole in the top of the part. All right. Okay, so we'll take just the first sketch, since that was fun, and we'll switch it over to millimeters, grams, and seconds. Not intending to that we drew it in inches, meaning that it was in millimeters. We drew it in inches, meaning to convert it to millimeters. All right, so when I look at this, pretty much the easy thing is the 63. That one's kind of a weird number. Yeah, most of these are not too far. You get out 2 or 3 decimal places in metric. You really, you know, 4 tenths, half a thou on all of these is going to be a little on the extreme side. So the 114.3 I could live with. The through bore, I'd have to consult the tube. Yeah, tube manufacturing. If that's going to stay an inch number, then this would be where I'd want to consider using the dual dimensions for that item. Oh, and since I switched, let's go back to the document units. Make sure that my dual units, one of them is in inches. And so we'll go to 2 decimal places, since that's already driving me crazy, and we'll go to 3 decimal places on inches, and 2.75, 69.85. So in our tube, American manufacturer is probably going to be 2.75 plus or minus, 10 thousandths or so. So again, verifying and being able to hold. And everybody knows the difference between pipe and tube. Pipe is held to tolerance on the ID. Tube is held to tolerance on the OD. So that 275 ought to be pretty close. Basically, the pipe, as far as steam and transmission of fluids, is to stay consistent volumetrically on the flow. Anyway, I digress. Things like the 304, I don't know that I care. That could be 300. Probably going to need to stay pretty close. These numbers make sense. Whatever this is fitting to, there's not a lot I can do here. Aside from rounding a few numbers, that is really going to help. So maybe the 172 is a non-critical. Oh no, that wasn't. I need that one because that was whatever flange fits in there. The outside body, we could go to 115 just to check it. All right, so a few minor tweaks going over to metric, but there's not a whole lot. As far as the tolerance dimensions that I'm going to be able to work with. All right, but as far as the threads, we should be able to find a metric thread. So 875, what's going to be in the ballpark there? That's going to be not quite. A 20, a 22, 24, probably not. So pretty much the 22 by 2. Okay, that's probably our choice there. 20 is going to be 787, and that's going to be up at, if we just did 90, that would be 30. So we're a little bit undersized, but I think that's going to be our best bet if we're going to switch them over. Of course, the 3/8 would go to an M10 by whatever form we want to pick. So, it's not really that big of a deal. It's just what makes sense in those conversions. So, all right, what else can we do to this one? I think splitting it and then saving the bodies was probably the worst thing I could have done to it, but. Hopefully that ties the contrast between the two parts.